Yeah. All right, so what would that antiderivative be for x cubed? Yeah, good. 1/4 x to the fourth. Sorry, the pause and stop buttons are right next to each other. And I didn't know if he needed to talk to me or something. So I was just going to pause it and I hit stop. Oh, well, life goes on. All right, so this will be u times v. So 1/4 x to the fourth ln of x minus integral v du. So you're going to have that 1/4 in there. And then because this is 1/x, one of the x's cancels. So x to the third dx. Here's what I would do. Just leave off the boundaries. Just ignore them for a second. You can write them in there if you want, but I'm just going to ignore them until I get to the very end. And then just don't put a plus c. We'll just evaluate it. All right, so this first part, just don't do a copy error. That's just going to stay. Minus, all right, and then what is that antiderivative going to be? Good, because it would be 1/4 x to the fourth times another fourth, so 1/16 x to the fourth. Don't put a plus c, put such that 1 to e, and then we're going to evaluate upper boundary minus lower boundary. So if we plug in e, ln of e, what's that going to give us? Yeah, that cancels. It'll just be 1. So if you plug e in here, ln of e, that's just going to be 1. So it'll be 1/4 e to the fourth minus 1/16 e to the fourth. And then if you plug in 1, what is ln of 1 going to give you? 0. So that makes that whole thing 0, and then minus 1/16. What's that? What a beautiful answer. Sarcastically, it's not bad. Oh, don't discriminate. Well, here, if you had to simplify it down, you would get a common denominator here. What would 1/4 be as 16ths? Well, you jumped straight to the answer. This would be 4/16. Well, well, follow me here. Do you guys see how this would be 4/16? Minus 1/16 would be 3/16 e to the fourth, and then these negatives would cancel, so plus 1/16. There, does that suit you better? I suppose. You like the other one better? Well, if it was multiple choice, you guys get that it would look like this. All right, so it's still an important skill. All right, we'll just do one more. This one has unit circle, my favorite. That's 3 pi over 2, and then that's pi. What's that? Yes, oh, good, well noticed. Oh, that's so cool that you noticed that. Well, because pi just comes before 3 pi over 2. Yeah. All right, what are we gonna let u equal? X, good. And so du would just be dx, which is nice. So dv is the cosine of x dx. And for v, you have to do an antiderivative. Sine, good. All right, so we're going to do u times v, so x sine of x, minus integral v du. So that's sine of x dx. And again, I would just leave off the boundaries for a minute. We're going to do this last antiderivative, and then we'll evaluate it. So it'll be x sine of x minus, and then this would be negative cosine. So minus negative, good. So plus cosine of x such that 3 pi over 2 is pi. So we're going to do upper boundary minus lower boundary. And we're going to plug in pi. I'm going to draw this off to the side. You can or not. I'm trying to illustrate every last little thing. Where is pi on your unit circle? To the left. All right, so that's -1, 0. We're doing sine of pi. So that would just be 0 times pi would just be 0. So sine of pi is 0, that first first part 0, plus cosine of pi. Cosine would be the -1. All right, and then 3 pi over 2 would be down here, 0, -1. So sine of 3 pi over 2 is -1, and then we're plugging in 3 pi over 2 for x. This would be -3 pi over 2 plus cosine of 3 pi over 2, that's the x value, so that's 0. So again, you can stop there, but let's pretend for a second that it was multiple choice and you had to keep going. This would be -1 plus 3 pi over 2. That one actually wasn't so bad.